Swayam Prabha. Digital India. Educated India.
In this lecture we will cover basically the precedence diagramming method, okay, and this is an alternative to activity on arrow, activity on node, and the third method we call as precedence diagramming. We will cover a little bit on the rationale, the history, the notation and relationships which are very important. We will do network analysis using the precedence diagramming method, and then we will work out some examples. Now what I would like to start with is, why do we need precedence diagramming, and for this I would like you to do an activity, okay. It's a small activity which requires drawing the network diagram for a pipeline project. So here you can see the image of a pipeline, and when in a project like this we know that we need to excavate, we need to lay the pipe, we need to backfill. I am taking it as a very simplistic model of it, and if we wanted to develop a network for this using the techniques we know today or we have covered so far, how would you do it? Can you briefly sketch what would be the network like? Right, I am only giving you 3 activities. I do not want you to go to surveying or anything. I am only giving you 3 activities. How would you represent the relationship between the 3?
Excavation precedes
right. So you would have an excavation. After excavation finishes, pipe laying will start. After pipe laying starts, backfill will start.
Or we can have excavation to certain depth, certain length, then start pipe laying simultaneously.
So if we took the first alternative where we have excavation finishes, and then pipe laying starts, and then backfilling starts, would you see, is that the way it would be done? No, obviously not, because if it's a few tens or hundreds of kilometers of pipeline, I am not going to wait till all of it is excavated and then lay the pipe. And like the second suggestion, we are certainly going to excavate a section of the pipe of the area, lay the pipe. While laying pipe is going on in that area, excavation is going to continue in the area. So if you wanted to represent this sequence now, so we know that at a certain stage there is going to be excavation on a section, there is going to be pipe laying on a section, there is going to be backfilling on a section. So if you wanted to represent this now, what are the options?
We need to put some delay.
We can go like,
you don't have delay in your activity on node, you only have finish start relationship and you have activity.
we can divide the work, the whole
right.
pipe into sections, and
right.
then we can excavate,
right.
lay pipe.
Right. You will have excavate, say section 1, excavate section 2, this would go on. What would be my next set of activities? So after I excavate section 1, I can lay pipe section 1, and then this would only after this would be lay pipe section 2, and then backfill and so on. So what is basically, so how many activities for just 2 sections? Now we have 6 activities, and if it is a very large project you will have many activities, hundreds of activities for a section. Now so in order to address problems, so if is there any other way you can think? Now go out of the activity on node. So this is with activity on node or activity on arrow kind of representation where we only had a finish start relationship, this was the only option. Now what precedence diagramming does is tries to overcome this with different kinds of options. So let me just go back. This is what we discussed on the board. we know that this does not represent the real sequence, so pipe laying may start 3 or 4 days after excavation, or backfilling may start 3 or 4 days after pipe laying. And what we have shown in what we worked out on the board is we have split all this into sections. Now what precedence diagramming tries to do is overcome this with an alternate representation. So it takes large projects like this and tries to reduce the number of activities, and this was actually something that came out of AOA, out of AON. Okay, the activity on node diagram which Fondal had suggested, it was taken up by a construction company called Zachary in the 60s, and along with IBM they made this precedence diagramming technique. So we will come to the details soon. The attempt was to get the advantage of AOA events with AON type representation. We briefly touched upon AOA earlier. What did we find as the problem with AOA? You have to create dummy activities, that's number one. Then
during branching of activities.
Right, it's not, you normally have to draw the network, then kind of redraw it, because it's not that intuitive to draw it, whereas when you went with AON we could flow through the network quite easily. But when you use an AOA, you will find that there is a start of an activity. You remember an AOA required the arrows to be in this form. I mean, you had the activity on arrow, and this was start and this was end of the activity, and this was the activity. So you had events. Now, so what the precedence diagramming method tries to do is to get the event based approach of the AOA, but the flow of AOA. Okay, and it is the default software in all popular scheduling, the default representation in all popular scheduling software. So when you open Microsoft project or Primavera or Open project, any scheduling software you open today which is popular, this is the representation. Now you can see the last point, PDM also has its issues, okay, and you will find that in practice there is a lot of discussion of how PDM causes, while it is powerful and flexible in its representation, it causes a lot of confusion for practical scheduling. And software does not use the same algorithm, each software does not use the same algorithm, so there are again differing results from different software, there is no standardization. So really professional schedulers have hesitation in using this, okay, but because the software is easily available, a lot of people start tending to throw PDM representations without really representing the project problem. Let us see how this can happen and issues related to this. Okay, so when we get into the basics of the precedence diagramming method notation, you basically have the AON type of notation. You can see that instead of the circle which we used for AON, you have a rectangle. You have the rectangle divided into various spaces, and these spaces can be filled with things like activity name, your early start, early finish, activity number, late start, late finish, floats. Depending on the type of representation, type of nomenclature you want, there are different software, different methodologies will use different values in these boxes, okay, but I have not put any specific value because it depends on the kind of tool we use. More interestingly, the PDM represents various types of relationships. So far we have been only using a finish to start. An activity should finish, so what we have shown there is a finish to start. AOA uses 3 other kinds of relationships: start to start, finish to finish, and start to finish. Okay, in addition to this, each relationship can be qualified with lead or lag, which says that, for example, this is a finish to start relationship. I can say there is a finish to start and a 2-day lag. That means the next activity will do finish to start after 2 days. The lag is represented in the relationship. I can have a start to start with the 2-day lag, which means activity which follows will start 2 days, can start 2 days after the first activity starts. We will get into some of these details. Okay, but this is the main difference. One is the notation is very similar to AON, so there isn't much to worry about there, but the relationships are significantly different, and these different relationships cause computational differences in the analyzing the network. Okay, if we take a start to start relationship, for example, here is a start to start with a lead lag of 0, might not be possible, but what this says is laying pipe cannot, okay, so laying pipe, so this is the successor activity, it cannot start earlier than excavation, that is the constraint. But is this acceptable? This almost says I can start immediately with excavation.
No.
Okay,
It says
not.
That, it says that you cannot start unless the excavation is finished.
Started. No,
No.
doesn't say that. Excavation is starting. Here is excavation, starting of excavation.
Laying pipe also.
So right now what this says is laying pipe can be as, I mean the constraint is it should not start before excavation, that's all. But I can start after excavation, but it is giving me up to almost immediately after, which might not be feasible. So something like this, which says laying pipe can start no earlier than 1 day after excavation starts. Okay, might be reasonable. You want to have some length of excavation done before you start laying pipe, so this gives you a lag relationship. Now we can, I am not covering leads in this because you will have negative relationships and you have to, we will just use the lag for now to illustrate the various relationships. Finish to start, we are familiar with this. You can have erection of form, install rebar, okay, as an example. So here it says installation of reinforcement can start only after erection of form is complete, and this is 0 lag. This is what we are used to. We can put another relationship like this: pouring concrete, you complete pouring concrete, wait for 3 days, and then strip forms can start. So stripping of forms can start no earlier than 3 days after completion of concrete pouring. Now a relationship like this, so for example we might decide you want some form of setting, or you could have, instead of, so what the finish start relationship with a lag replaces is another activity, okay, or you can't say pouring concrete and then I am going to keep another 4 days for just pouring concrete, it will not be represented. But at the same time when I put a lag, I do not know what the lag is for. The activity for which the lag is represented is not clearly represented in the network. So that can cause some kind of, sometimes a little bit of uncertainty as to why did the planner put the lag there. Okay, but from an activity perspective it reduces the number of activities in the network. Finish relationship. Okay, so for example the backfilling cannot be completed until the laying pipe is over. Okay, so here we have said no earlier than completion of laying pipe, or we can say backfilling can be completed no earlier than 1 day after laying of pipe is complete. Okay, so you have got the idea of these at least the 2 new relationships we have discussed so far: start and finish. Now we come to a kind of unusual relationship, which is start to finish relationship. Okay, so far we have talked about finish start, and it is very so this relationship actually is not used frequently. It is not a finish start relationship, it is a start finish relationship. So here is an example, okay, and it's quite, you do not come across the kind of situations where you need to use start finish frequently. So here is an example. You have, let's say you have 2 shifts, okay, so we can discuss this a little in terms of, I want to represent that shift 2 will start
Before shift 1 ends.
Before shift 1 ends. Is that the way I am trying to represent this? No, what am I trying to represent?
Finish before shift 2 has started.
Right, it is not that shift 2 can start when shift 1 has ended, it is that shift 1 can end only after shift 2 starts. That is, the people on shift 2 have to come in.
Only when shift 1.
No,
Can come in when
shift 1 people can leave only after shift 2 people have come. Okay, so again you can see that this is, and it's, I have not come across many situations where this is used in kind of construction scheduling. So it is not a common relationship, it is not rarely used, we might not see it in practical applications, but but when you have to do calculations with it, it's just applying the same kind of rules in a different way.